Good morning, guys. My name is Hugo. I will be presenting Introduction to Custom C++ Shop. I think it's an interesting subject because there's not so much documentation online on well, there's a starting point on the derivative documentation, but most of the hidden secrets are inside of the actual code. So you have to find it first and then dig inside of every method, function. And so it's always kind of hard or intimidating to get started just doing it, even coming from a C++ background. So what I'll do is, I'll show you the agenda, so it's not too complicated. First of all, I think setting up the tools, always the longest, hardest part. Afterwards, we'll be compiling our first custom DLL. So looking at the example we have already inside of Touch, how we can modify it, maybe add a couple of settings, and have it running inside of TouchDesigner. Afterwards, I wrote a small 5-minute break, but mostly grab more coffee. And if you've seen, I brought some Wiimotes, because this is for the second part of the workshop. I think I tried to find a small device we could all try and integrate inside of TouchDesigner. And I found out the Wiimote is a great fit. So does everybody have a Bluetooth on their laptop? Yeah? And everybody, are you all running Windows? Yeah? Okay, cool. So that's great, because I have absolutely no experience in Mac OS at all. So yeah, so about me a little bit, well, as you can know, I'm a creative coder from Montreal. So I've actually studied in UQAM, so that's nice to be back here and presenting a workshop here. I co-founded the studio called Automata 2 years ago, and we do interactive installations, immersive stuff, basically like a lot of you guys. But before that, well, I've been working in this field for like 4 or 5 years. And before that, I've been a lead developer in other startups, mostly tech startups like Connect and Go for RFID wristband stuff and developing. So not necessarily inside of TouchDesigner, mostly in C++ or Node.js also. And I've been programming maybe for the past 13, 14 years. So I have a big background, also a background in electrical engineering. So that's why I like to play with new toys and try to make it work inside of Touch. And also maybe why I chose the custom chop today and not any other topic. Well, as soon as you understand one, it's going to be easier to understand the others. And one great thing about the chop is you might often be in a case in TouchDesigner where you want to integrate a new detector like a SICK LiDAR, a Wiimote, why not? And the tools are not there inside of Touch. So you have to create your own. So that's why I think, okay, maybe starting with the chop is a great starting point. So yeah, and maybe since it's the first workshop of the weekend, I thought maybe everybody can present a little bit themselves, what they do and what they hope they can find during this specific workshop, what you want to get. So maybe if you want to go ahead. Cool. So thanks, guys. And I think we can get started. One thing, I sent an email this morning with a link to a code base. Did you actually all get the chance to open it and maybe download it? If not, I have it on also on a USB key. But what's interesting is if you just open the link, there's basically a markdown file that you can follow along. And what I suggest is, well, basically today we're going to all be inside of Visual Studio and kind of just writing some lines of code. And to ensure everything goes a little bit faster, I've already put some shortcuts inside of the README file. So some places you might see like click to show the solution, and you already have the code example. So that can go faster a little bit, because sometimes there's big chunks of code. And so I encourage you to follow along, and if you get lost, refer to the file. Also, never hesitate to just stop me, because I might not go fast, but some things I might see as obvious, because I've been doing it a lot, that are not that obvious. Just stop me. And if you have any questions at any moment, just stop me again. So I think we can get started. So, well, first thing first, like we discussed earlier, there's already some documentation on the derivative blog, well, the wiki, which I usually open and keep open in a tab, but like it's great to get started. But when you get inside the core of the code, there's not much information, but at least you can refer to it when you begin a new file or a new project. Also, I keep open in another tab the C++ Bible, which is basically the whole C++ reference. You get all the core libraries, descriptions, all the functions you might need to use. Also, of course, Google is your friend, but I think we can all agree on this to find some stuff, or on Stack Overflow. If you have some basic crazy questions on C++, it's great to have it. So maybe just open it in some tab. And like I said, we all need, since we're on Windows, I recommend Visual Studio, not because I'm a big fan of Microsoft, but there's a community edition. It's easy to install, and you have all the tools, especially since we're developing on a Windows platform. So hopefully everybody installed it before coming here. If not, there's a link you can already follow and install. Also, there's some libraries, basic libraries you need installed. I think everybody hopefully did it. And the first step is finding the demonstration code. So if you go ahead and open TouchDesigner, you probably did it a little bit. If some people said they fooled around the code, and so maybe you've already found it, but there's a dialog or a help. It's called Browse Samples, and you have a lot of great examples to get started, but what we're interested is C++. And like we mentioned, there's OpenGL top, CPU memory top, a lot of cool toys, but today we're going to focus on the chop. So to get started, what you can do is basically copy this code inside your working folder. So this is what we're going to do right now. So go ahead and create one folder wherever you like to work. And call it something like workshop chop. So it rolls in the mouth. And inside of this, you can just go ahead and copy the code. You can also close TouchDesigner after. And if you are familiar with Visual Studio, you will see you have your solution file, which is called C++ chop example. So you can go ahead and open it and already see if you have the correct settings. Like for myself, you see it tells me that I work on a different Windows SDK version and platform toolset. I can just accept these settings. If you don't have this pop-up, it's also normal. It depends on what the libraries you have installed inside of Visual Studio. But after that, one thing I also like to do is renaming the project. And just renaming a project in Visual Studio can be kind of hard for no reason at all. But let me walk you through the steps. But if you ever forget, it's in the README. But the first thing is you can right-click your solution and just rename it. So right now we can call it Workshop Chop. Well, it was the project. Same thing for the solution. You can rename it. So the two name at the top. Yeah. Inside of which? In the GitHub. Do you have the WemoteShop.sln? Okay. And when you copied, because this is maybe for the later part of the workshop. No, that's fine. But let me just go over it real quick. You know, inside TouchDesigner, just open Touch. And in the Help menu, there's the Browse Samples. If you click on this, you have the Windows prompt opening. And inside of C++, you have inside another folder chop. This is basically just copy this folder because we're going to get started with the example file. It's good? All right. So right now you should have your solution. Okay. And once you open it in Visual Studio, at the top right, you have your Solution Explorer. You can just right-click and rename this one. Well, the two top, which it's kind of small. I cannot zoom in this part. So once you have those two names changed, one last place you need to change it. Inside, if you click on your project here, at the bottom right, there's a thing called Properties. You can also change the root namespace to the name of your shop. So workshop shop. By the way, changing the name doesn't really matter because it's going to compile anyway, but it's just, I like to keep everything kind of in its own box, clean, so I like to do it. And this is where the magic of Visual Studio comes in. Now, does everyone have the file renamed? Okay, you need to right-click on the project, and you have to remove it, and you have to save. So basically, the solution should now be empty. If you don't have it, you can press F4. It should appear in the bottom. Also, if you click on the project, let me just re-add it so you can see. Do you have this window at the bottom right, properties? And if you click, you don't have it. It should be if you click view at the if you click view on at the top, and the properties window, it should be right here. I don't know if do you have it? Okay. So, like I said, after that, okay, maybe a little bit, yeah. Once you're done, you can just right-click basically on your project here and click remove, and you have to. It's going to ask you if you want to save. You say yes, and you close Visual Studio. It's the worst, like it's the worst path, but it's the only way to kind of do it. And inside of your folder, you should have a file C++ shop example.vcxproj. If you don't see the extension, it should be type VC++ project. This, you can rename it to however you like. So workshop shop, once again. And now we're almost done. You can reopen the solution. Oops. So I basically broke my thing. Okay, and then you can re-add the project by inside of your solution. You right-click, you go and add existing project, and you navigate to your folder. Yeah. Just the Solution Explorer. It should be in View. So the first one, Solution. Is it? Do you have it? Okay, good. I just need to find my source file. I kind of got lost just by switching around all these files. Uh, oh yeah, and you might, I forgot, you might also have a vcxproj.user. You can also rename this to the correct name. Then you can open the solution. Okay, so do we all have a project open? Yeah, okay. Uh, I'll also give you one quick tip. When we're developing inside of Visual Studio and inside of Touch, you don't have a command prompt, so it can kind of be hard to output some stuff, just some text stuff, if you want to debug and output some messages. So you can set one environment variable to one in order for the TouchDesigner to open a command prompt for you. So basically, inside of Windows, you can search for environment variables and open it. If you look at if you just search inside of Windows environment, you can see and exit the system environment variables. Open this menu, and inside of environment variables, you click on it, and then in the system variables, you can create a new one, and just call it all caps touch underscore text underscore console. So if you want to, it's kind of small on the screen, but if you want to have a look at it and set it to 1. And so every time you're going to open Touch, it's going to open a command prompt. So that's kind of useful to debug. So accept everything. Yeah. Okay. So right now you have Visual Studio open, and it says like 0 project. Okay, you can right click and click Add, and then Existing Project, and then navigate to the folder where you have your source code, and you can add the vcxproj file, and it should be there. Okay, so once we have all of this, we can just go ahead and just at the top you have build. You can click on build and click rebuild solution, and just see if everything like still works. Yeah. Yeah. You want me to show you again the environment? Okay. So basically, inside of the Windows button, you can just search environment. If it's in French, maybe variable environnement. But you should have a prompt like this: edit the system environment. Just open this, and at the bottom right, there's environment variables. Open this, and then in here you have two places. In the system variables, just create a new one right here. And so, like I said, all caps. I'm gonna write it, but I won't add it. It's a touch underscore text underscore console, and here you put a 1, and when it's done, you click OK. And if you want to stop it, you can put it afterwards. When you're done, you can put it back to 0. So it won't open every time because after it's always on. So yeah. So you have to click OK after and close all the windows. So and like I said, when this is done, you can add in Visual Studio. You can go back and then the menu. There's a button called Build. You can just click Build and Rebuild Solution, and in the output section at the bottom, you should see like some stuff appearing and see one succeeded. If it doesn't succeed, there's a problem. But if it succeeds, you successfully change your file, your project name. So congrats. So if we take a look at the code, you can see there's already like four files over there. You have the chop C++ base, the C++ common, and 2 other files, C++ chop example, and well, both the header as well as the C++ file. If we're what 2 files you're going to look at are the C++ common and the chop C++ base. The C++ common is a file that's shared for all the ops, so the top, the chop, all of them, they basically start from this file. So you might find some interesting stuff, and like if you just take a look at it right now, you see there's a lot of comments inside of these files. Let's just look at it. Op custom op info, used to describe this plugin, for all of the parameters, op string, the type name of the node. So you can already see the TouchDesigner language inside of this. So you're gonna go back and forth when you write code and look at this. It's very important. And then after that, you have the chop C++ base. Basically, this is the core of the chop object that is located over there. But you will never have to modify these 2 files. They're like basically the core structure of the op. The 2 files you're going to have to modify are the other ones. So right now we can close the other 2. So C++ chop example and C++ chop, well, both of these files, this is where the code will go. After that, if you're familiar with object-oriented programming, you're going to add objects and like link to them, but all from this file because this is the core. And yeah, so also these 2 files, you can rename them, so you don't have like C++ chop example. So for this, you can just right-click, once again, rename the file. I'm going to call it workshop chops to say to stay consistent. And the same thing for the header file. And once you do that, you will have to modify the reference inside of the .c+cpp file. You see it says at the line 11, include C++ chop example.h. This is wrong because we just changed it. So change it to the file name you created. And is it big enough so that you can see? Yeah. And also, well, since we're doing C++, we're working with objects. So we're going to rename our object. So if you would go inside your workshop chop header file, the .h file, you will have the class called C++ chop example that extends like I said, the chop C++ base. You can just go ahead and modify this. So I like to start my objects with a capital. So workshop chop. It should change color if it works. And right after that, you're going to see that it throws an error right here because we need to rename our constructor and our destructor. Are you guys familiar with this concept, the constructor and destructor in C++? So just rename those 2 to the workshop chop. So this is the only thing we need to modify in the header file. And then once, I'm going to wait a little bit maybe. Whenever you're done doing this modification, you can go back inside the C++ file, and you're going to see a lot of wrong references to the old object name. So you can just replace all. So the shortcut for that is Control H, and then you can find one instance of the error message. So I'm going to select this and copy it. So I'm looking for C++ shop example, and I want to replace it with workshop chop. And there's the button right here, which it means replace all. Yeah, so once again, some shenanigans to get started. So the shortcut for replace is Control H. So here you put what you want to replace, and here what you want to replace with. So once again, once this is done, save the files, and you should have your compiler at the top already. By default, it should be set to debug. If you look at, it's kind of small once again, right here, debug x64 if you're on 64-bit system. Just try and run the debugger by clicking on local Windows debugger. You should have an error message, but at the bottom, if you look at the output, it should say build 1 succeeded. So the meaning of this is because, let's just compile again and look at the message. Unable to start program, blah, 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 the location of the file, workshop chop.dll. So basically, when you work in, well, it's a custom chop, you compile dynamic link libraries. So just to go real quick on this concept, the DLL is kind of a program that is linked to the current process at runtime. So it's a set of functions and functionalities you can use inside your main program while it's running. And when it's done, you can just discard it and keep running in your main process. So, well, if you've ever loaded a custom DLL, you might be familiar in TouchDesigner with the C++ chop or C++ top, where you have to link the .dll file. So this is normal that you have this error, because you cannot open a DLL and run it as a standalone program. It's just a new subset of functions you can use. So what's great about using Visual Studio or probably any other IDE, but is that you can say, link this DLL to this program. So basically what we're going to do now is we're going to say, tell Visual Studio to open TouchDesigner and link the DLL library with the program. So how do you do this? You have to, once again, on the project, you can right-click it and go inside of properties. So now you have another property window. And inside of, let me just remember. Okay, inside of configuration properties, debugging, you should have these two places, command and command arguments. So command basically is going to be the TouchDesigner X file. So you can go ahead, click the small thing, and click edit. And right here, you can remove what's already written. It doesn't matter. But now you need to navigate on your system and find the location of TouchDesigner, the X file. So by default, yeah. Okay, so if you don't have it, maybe do you have this configuration right here? If you click on configuration and choose debug, and platform active, choose the x64 if you're, I think you're all on 64-bit. And do you have this menu here, configuration properties? Do you have debugging right now? Okay. Let me just check. Okay, did you right-click this one correctly? No, the one at the bottom. So this is the one you chose? Yeah. So do you have these settings right now? Okay, good. So now just go ahead and navigate to the default installation path. Normally, it should be on your C drive inside of program files, derivative, TouchDesigner, bin for binaries. And if you look at the bottom, it should be right here. But you can just go ahead and copy this line, add it, but you need to add the backslash and then copy. You can write it down if you prefer, but basically TouchDesigner 099.x. Then you need to accept. So I'm sorry. Yeah. Well, you can use either a slash or backslash, but just if you copy with backslash, you need to say keep using it. But you can just copy paste. So once this done is, you can click apply, and then you can try to recompile again. And now something different should happen. You can see the debugger has started actually because of all the menu on the side, and and also TouchDesigner should start. So you have two copies of the same header. Okay. Do you? So if you close all these files at the top, and inside of your solution, do you see more than one copy of the same file? Okay. So now reopen the header and do you have the correct settings? If you look at line 30 to 33 and 34. But maybe you modified the other one. Because if you have something about Visual Studio, if you have two times the same file name, but in a different folder, it's going to open it anyway. So you might have modified the wrong file before. So that might explain it. But yeah. No, inside command. Let me show you again. You see right there, command. Because the other one is command arguments. Okay, so okay. I don't know. Okay, so now does TouchDesigner open? And like I said, you should notice that inside of Visual Studio, you have the process memory and the CPU usage. So your debugger is running right now. And so if you go back in Touch, one thing I'm going to do is just save this project, even if it's the default one, but save it inside of the source location where you are working for the chop. So and what I like to call it master or whatever. What do you mean? Okay. Okay, if you have a default touch project, you should, where you wrote the command, in the properties, there's the command field, but there's the command argument field. Okay, no, because you changed your default project. Okay. Okay, but you can just close it, and if you compile, does TouchDesigner open by itself? Okay. Okay. You can close it, all of Touch, and compile and keep the one that opens by default. Use this one, and like I said, save the default project and call it master, something like that. And then you can delete everything you have because we don't need this. What we are going to need is to create an op, a chop called the C++. So you should have it inside of the chop settings. You can just go ahead and drop it. And it should say an error because there's no DLL linked. So this is what we're going to do right now. We're going to just click on the plus and navigate. By default, it's going to, if it doesn't open in the same folder, you just need to navigate to your solution, where the solution of your project is located. And you should have a folder called debug. And then you should have workshop chop.dll. You can just load it. And basically, you're going to have a sine wave running. So that's the default object that TouchDesigner gives you. So once again, when you're done, just click Save. And does everybody is it working for everybody? Okay, but so when you compiled, did it open TouchDesigner? It's open by default? Okay. Okay, when you compile here inside of Visual Studio, if you click compile, does it open TouchDesigner? Okay. Did you do you have any errors at the bottom in your output? I don't know if it's maybe it. Probably. Okay, when you click on the project and you go into properties, inside of debugging, is your command correctly set? So it says touchdesigner.exe. Okay. Maybe I can just look real quick. Okay, yeah. And if you close it, and if debugger, clique sur. OK, oui. OK, un échoué. OK, fait non. Fait non. OK, include. OK, si tu double-cliques sur le premier. OK, c'est ça. Fais celui-là. OK. C'est parce que tu ne peux pas inclure le fichier. Comme ce fichier-là s'inclut lui-même. Oui. En fait, c'était quoi qui était écrit là avant? Ça, je ne me rappelais pas. Il faudrait que tu fasses CTRL-Z. Peux-tu faire ça? OK, c'est bon. Puis là, si tu vas dans l'autre, celui-là, dans ton autre fichier, ouais. OK, ça, c'est bon. OK, oui. Ça, c'est bien fait. OK. Mais là, si tu retournes en arrière, dans ton autre fichier, tu vois ici, il faut modifier le nom de la classe. Ah, d'accord. Okay. En fait, puis là, moi, je l'ai appelé Workshop Chop, pareil comme tu as fait, mais je mets une majuscule. Regarde, je vais ouvrir le fichier, puis regarde, tu vois-tu qu'est-ce qui est écrit sur l'écran? Workshop, c'est exactement ça. Puis il faut que tu modifies comme ça. Ouais, là, il va falloir que tu modifies les deux autres qui sont soulignés en rouge. peux juste copier-coller. Ouais. OK. Là, ouais, c'est bon, enregistre. Puis là, si tu vas dans ton autre, ton autre fichier ici, ouais. Là, avais-tu déjà cherché? Si tu descends, je veux juste voir, descends plus bas. OK. Et ici, si tu mets dans remplacer, fais coller, fais coller ton truc. Puis copie le nom C++ Chop Example. Ouais. Puis là, si tu le mets dans le premier, ouais. Puis là, fais le bouton, non, en bas un petit peu, à droite de celui-là. Ouais. OK, vas-y. Puis là, si tu fais debugger Windows, oui, tu peux accepter. OK, cool. C'est bon? Pas trop? OK. So now, it's not very exciting to just have this small sine wave, but if you still have it open, you might have noticed that in the properties there's a tab called custom with some properties like well, I will need to re-add it, but basically different properties. These properties you can modify it in the code. So as a first project or hands-on example, I think we can try to add a new toggle. And getting started with there, we're going to choose what it does, maybe add all the chants together or something like that. So you can go ahead and close TouchDesigner. And now that we've created our test project in TouchDesigner, you can link it also inside of the project settings. So once again, you can right-click on the project, and inside of the properties, exactly at the place where you added the .exe location, there's another one called command arguments. In this, you just link it to your new .to file. So for me, it's master.to, so I'm going to have to navigate and find it. But if it's not named, if it's named with another name, just write down your correct setting. It should be called, for me, it's master. You can click apply. And just to test if it still works, you can compile again. And now it should open with the master.to you created earlier. So on my side, it works correctly. I have my sine wave right here. And like I said, you have some settings like the scale, the speed, the shape, and maybe you can notice something. If you connect something like a noise or whatever, well, the behavior changes. Let's. I'm just gonna create something random, but. So you see, it's not creating a sine wave. It's actually adjusting something in the input. So you can have different behavior on your chop depending on what you have at the input. So like I said, for now we can just close this file and go back inside our file workshop.chop.c++. And so if we take a better look at this file, you can just scroll down a little bit. And already you can see some nice information. You got the field chop plugin info. So here you can see the name of you can set the name of the chop, how it's going to appear in the menu, your name, because you want to get credits and stuff like that. But if you go down a little bit further, you will see the constructor, the destructor, which has nothing. And you should get some information. If you go down at line 130, you should find execute. So this method basically is the main method called for this object. Basically, it gets called every frame, the number of time of the sample rate. Basically, if your chop compiles at 120 hertz, it's going to be called twice every frame. And so that's all the core of the logic is there. And if you just by looking real fast, not necessarily need to understand everything, but you can already see enable par speed, enable par reset. So you can already see what we've seen inside of TouchDesigner. But this is the logic place. It's not where you create the actual buttons and settings. If you keep scrolling down inside of the code, well, you're gonna find some other interesting stuff like the get info chop or get info dat. So we're gonna go on this topic later, but keep scrolling until you find the function called setup parameters, and this is exactly what we need. If you take a look, you've got speed, you got scale, you got the shape. So basically every setting that was inside of the chop. So one thing we can do is create our new, let's say we want to create a toggle that when we toggle it on, it adds all the chan together. Something basic like the math, small math function. So I think we can just inspire ourselves from the code already there. If you look at the pulse code, maybe copy it and create your object, your parameter, and let's call it, let's be creative, like a combine. Very nice name. And you can go, like, this is pretty straightforward. You got the name, the label, and also, if you just take a look at the line afterwards, par append result, res manager append pulse. So you just by looking at it, you know it's great, but it's not what we want because we don't want a pulse, we want a toggle. So maybe you think a little bit, you can say, okay, maybe append toggle exists. But if you want to take a real look, you can go inside of the C++ common, and let's say we want to know if it exists for real, and copy this this function name and search for it inside of the C++ common. So exactly what, like I said, you can see at line 1300, stuff like that. You can see a lot of things, append UV, append XY, append XYZ. So this is why it's interesting to go back and forth between these two files. You get some information. And for now, we just need the toggle. So basically, copy this function, go back and replace the function right here with append toggle. By the way, like I said, if you get lost, you can just go inside of the GitHub repository. You have this example code at the step 1. One thing that's interesting also, I don't know if we can see it, but you can set a default value. If we can, yeah, that's why. If you just look, but so much information is inside of the code already. So if you just look before NP default values, the min slider, stuff like that. This is not a slider, but let's say we want to have it false when we open the project. So maybe you can just create a value like this. We can copy it or either write it down yourself. The NP default values 0, because it's the first parameter. We want to put it to 0. And then we can go ahead and save this. So we can already test if it works. Oh, good catch. So this is stuff that happens quite frequently. You're going to compile random stuff that don't work as intended just because you're not paying attention. All right. So now if we compile it, just to test if it works. And if we go inside our custom parameter page, you will see already combine. So right now, doesn't do much, but at least it appears. Yeah. Yeah. Okay, so in order to link the basic project, inside of your solution, you have your project name. So right-click this and properties. And right now, I have it on the same page where I linked the TouchDesigner X file. Just below that, you have command arguments. You can just put it right here. So either the full path or a relative path, but I like to, well, for the moment, it's great to have the full path. So do you all have like the custom parameter appearing? Okay. So let's say like we said, we want to add all the chants together when we click it, and then stop it when we don't click it. So by the way, this is almost the end of the main file. You can see after there's pause pressed. So you already seen all of the main code of the chop. So if you go back at the top, you're gonna find a function called getOutputInfo. So if we look at it just real quick, it's not super long, but like you can see, if inputs get num inputs higher than 0, return false. Otherwise, you return true. So basically, if you return false, if there's an input connected, you return false. Returning false means that it's going to match the input sample rate, the input number of chan, the input, all is going to copy this. If you return true, like in the other place, you basically create all the channels by yourself. So this can be important. For instance, if you create your own object, you can do it here. So right now, I think, yeah, so since we want to combine all the chans together inside one chan, Does it work? Yeah, but there seems to be a menu option. Okay, thanks. Inside of tools option, text editor, all language. Let's go check. Options, text editor. There's a lot of options. Okay. Well, I don't know. I don't know real quick about this. So do you have any other problems? Yeah. Okay, I can check real quick so we can go further. Okay. If you look at the settings, just maybe close this. Okay. If you go right click on this, properties, debugging. Yeah.
I just changed the file name from the. No, it's the directory. The C++ workshop directory. Yeah. Okay.
One thing you can write is if you are did you put your .to file in the same directory?
I did, yeah.
Okay, so remove everything before the .to file in the first part of the other window.
Okay.
This one. No, here where it's white in the background. Yeah. So just keep remove everything except the .to file. And so yeah, you also remove the backslash and write $, parenthesis, and it's with a capital solution,
Oh, right.
capital D, IR. Okay, so
And then it's back.
yeah, try no, remove the back. Yeah, just like this.
Okay.
Click OK, and apply. Okay, and try this. Hopefully, it fixed the issue. Input. Did you have an S? I think you need a.
I think I missed.
Okay. Well, so what does it say now? It should probably be cannot find parameter reset. Okay, so probably a missing parameter, but at least you're okay. If you can click stop, the small stop button. Yeah, put an S.
A what? An S.
Yeah, at the end inputs. Yeah. Okay.
There we go.
Okay, but the reset, that's kind of strange. Why it doesn't? If you go inside of the custom, it should be the default. No, okay. Cannot find parameter. Did you maybe you by mistake did you remove?
The output that I think I missed.
Okay. If you once again when you can always click close. Yeah. Go inside at the end inside of get where you created the toggle,
Oh, right.
the combined toggle. Why? Okay. If you go just a little bit higher, you have once just trying to see if the reset still exists. Go up. Okay, this is why the reset is not even there. So one thing you can do is go back in your execute file, in the execute function, and comment out everything where basically where you just spent most of the code for the past. Go back there, and here you can comment this out, the reset. Yeah, and there's another place I think down there. Maybe here you can just comment this. Okay, and try to compile. Okay, cool. So that's good. Yeah. So 3 noises with different seeds, all inside of one merge, and then you can connect the merge because it takes one input only for the moment. So yeah, I think I can just follow after that. Yeah, for the total. Yeah, so I think we can. Well, I think we were waiting for some compile errors, but right now this is something we can check. And I also think maybe there's something missing because I don't see it working. But this is part of the job, you know. Maybe we forgot something somewhere. So if we can compile again and have the TouchDesigner open, this is where we can have the debugger coming very handy. So we can check in real time the value of the vars. So what you can do is have TouchDesigner on one side, and on the other side, we have the Visual Studio window. And so one thing, if we want to test if our logic really works, we're going to go inside of our code. So if it's combined, we want to know if the total really adds really adds for real or if it doesn't work. So we're going to put some breakpoints. Breakpoints, if you're not familiar with them, is that whenever you reach this line, the program is going to pause and show you all the information inside of memory, so you can have a look point by point, var by var, what the value is. So I'm going to put one breakpoint here because maybe it's around here that I think that the mistake happens, and maybe inside of this loop, so I can see can we go do we really go inside this loop? Maybe it's a mistake on our side, and one after the loop. So we have 3 chances of hitting the breakpoint. So what we're going to do is we're going to go back inside of TouchDesigner, and when we're ready with the breakpoints, we can just click on the combine, and it should automatically trigger the breakpoint. So right now you see there's a small yellow arrow on the left side. This is, right now the program is running, but it's paused. So if we take a look at the bottom left, you can see a lot of stuff like all the C input, the inputs, the J value for the for loop. You can see output. So basically all the stuff you want to look at. So also you can hover over certain vars to see the value. So like I said, the J, the num samples, maybe the input. Bon. And you can also have like extend the vars to see more information. So right now what interests us, so J is 0, and we have only one sample to do. Okay, do we have the number of chans? You see it says some rubbish stuff because the number has not been initialized yet. If we click at the top left inside of Visual Studio in the menu, there's a button called Continue. So you can just say go until the next breakpoint. We click it. Okay, so mine, it just went inside of the loop. So at least I know I can hit this loop. That's great. And if I take a look at numchan, I got 3. That's good. If I look at, well, I can't look at touch because right now it's paused. But I know that we had three noise connected. So this is good. We have K0 total. Right now it's worth 0. So if I click continue, it should hit the same breakpoint a second time because we're in a for loop. So let's try again. So yeah, it did go further, and now my total is minus 0.0. Well, everybody should be different because we don't have the same noises. And if I click breakpoint, continue once again, the total changed once again. And another time, it should exit because we have only 3 noise. And if I take a look at the total, well, from what I'm seeing, output channel 0. Well, is it? Yeah. So the total seems to be correct. So let's click continue. So yeah. So basically, if you've seen it went back to the beginning. That's because we're 1 frame further. So right now, you can just double click all the breakpoints to remove them, and click continue. And now the process should be released and go back inside play mode. So the total seems to be working. One thing we could do is compare with maybe like a math or something like that. But for the moment, let's just assume it worked from what we saw in the code. I don't know if we're gonna skip this part because it's kind of long, but maybe it's important. Let's say you want to work with multiple inputs, because right now we just have one, and we're kind of stuck with this. Uh, what's nice is that we already have some code base that's kind of easily modifiable. So let's go ahead and stop. By the way, every time I want to stop my process, at the top of Visual Studio, you see there's the button, the red square. You can just click red. The red square is going to stop debugging everything, and it goes back inside of Visual Studio. So if we look at the code, we can see that at the line, just inside of our loop with the samples, we have this line called inputs get input chop 0. So you can already see the kind of the mistake. You're hard coding a value inside of it. Maybe you would want this to be like dynamic. So how can we do that? Well, first of all, let's have our number of output dynamically linked to the number of input. So to do that, you remember when we modified the get output info. So go back to this method right here, get output info. And here where we did our old code, bool is combined. Right here, there's another thing that's not very great when you force the value to 1. Let's have this value fixed based on the number of inputs. So we already have a great function right here, inputs get num inputs. We can just put this inside of the number of channel we want to output. So right now, if I connect 2, 3, 4 different chops, it's going to do the same logic, I'm sorry, for all of these chops. But now, let's go back inside our logic code, our execution. Right here, we have to have a way to modify this. So if you take a look, we're already inside of one giant loop saying int I, basically until I hits the number of channels. So right now, since the output of the number of channels is dynamic, if we have 3, we can go upwards to 3. So we can just go ahead and here, instead of putting 0, we can use the variable called I. And another thing, since we hard-coded the channel to 0, it's important now to change it back to the dynamic var, which is I, once again. And, well, if you were to compile this, there would still be something missing. You can see our total, we put it outside of all of our loops. So thinking a little bit ahead, you know it's going to add indefinitely. So let's change the variable initialization. And let's put it inside of the number of sample. Basically, every time we're going to create a new sample, we want it to restart at 0. So let's put it here. And so now we should have something a little bit more dynamic. So let's try and compile. Hopefully we didn't break anything. So if we combine, okay. And let's say we just copy this, create another one, and also change the seed so we have something different. And so if you connect it, you might find that nothing happens again. So this is classic. Honestly, it happens a lot. But so maybe we missed something. So let's go back inside of the code one last time. And just by scrolling up, you're going to see that one important method exists. It's called getChannelName. It's basically between the execute and the get output info. And right now, you can see the name is called setString chan1. So let's put a breakpoint right here and see what happens. Okay, so right now I already hit it. So If I take a look at the index, I got 0. And then I click continue. I got a new value of 1. So you can see that the logic of the index seems to be working. If I click continue again, 0, 1, 0. So basically, this gets called for every channel output you want to have. So maybe hard coding a name as chan1 is not the best idea because you're overwriting your own data. So let's go ahead and stop our process and remove the breakpoint. So this might be the only thing left to modify. So instead of having this name to chan1, let's work with strings. Maybe you're familiar with string in C++. Right now, we will need to include the library because it's not included. So if we go at the top of our C++ file, we can just include it over here. So include string. And you can see you already have this one, but it's not the same library. I think it's the basic C version. What we want is string like this. So once it's included, we'll be able to modify some string. So let's go back to the get channel name, and let's create a string. So since we never defined our namespace, so we will have to hard code it by hand. It's a std. I don't know what it's called. Not semicolon, double dot. I don't know how you say that, but std string like this. It should color if you included correctly the library, and let's call it maybe chan name. And maybe let's say we just want to have it increment based on the index. So chan plus index. One thing that is it going to work? Okay, seems to be great. But just to be sure, index is an integer. So we just need to modify it to a string. So there's a function also inside of the std namespace. It's called toString. So if you write std to underscore string and inside of the parenthesis, great. So now at least we know that the index is going to be cast as a string. And finally, we just put the chan name inside of the name. And it's going to throw a small error. It's because this function, if you look at it, maybe you don't have this. When you hover over function, it can give you more information, but it's looking for a constant char val. This is like a basic C string, and we're working with a C++ string. So you can just dot and use this function. It's a real basic function you might use often. It converts a C++ string to an array of characters. So now it doesn't seem to have any errors. So if I compile again, okay, so we will need to recreate our noise, but just testing real quick. So you should have now starting at 0, 1, and if you just copy a lot, you can have a multiple and should increment. Oops. Well, so you can see that now the name is more logic. It's based on the number of inputs instead of being hard-coded. So of course, this is like the example file, so that's why not everything is the best standard. But now we have enough things to start getting like deeper inside of the code. But you want me to show back the code? Yeah. So basically, this is how you can modify. You can work with any type of string, or you can put anything. This is just basically an example. But one last thing before going forward inside more deep stuff. Another way to debug, you know how in TouchDesigner you have the info chop and the info dat? Those are two nice tools to have because they can put some information. I usually use a lot the info dat to output maybe a status of a detector or a string of what it's doing. Otherwise, you need to have breakpoints and stuff like that. It's not very helpful. So TouchDesigner, Visual Studio gives us a functionality to do that. I'm just going to see if I can split my window in two. I don't know if I can do that. So I can have this code. But if you want to find the code, it's in the README in section like step renaming the channel. So step 5, you can find this code snippet. But if you want to output some stuff in InfoDat and InfoChop, there's 2 functionalities for that. Near the end, you're going to find a method called getInfoChopChans, and well, the getNumInfoChopChan and getInfoChopChan. Basically, here you return how many custom values you want to output. Right now it says 2, and if we look just underneath here inside of getInfoChopChan, you also have exactly 2 custom values. So you could modify this one by calling it 3 and adding a custom value here. But for now, let's just focus maybe on the dat. So right here, same thing. How many rows you have, how many columns you have. Let's say we want to add a new row. And so let's put it to 3. And then just underneath, you have the get info dat entries. This is where you're going to output the information. So once again, just by looking at the code, it's kind of self-explanatory. So you have 2. Right now we're going to add another one. So maybe copy this one to get started. And put the index to 2. So just right now, let's say we just want to have the total of all the totals that we just created. Let's call it set string. So this is the name that's going to appear, total. And now there's already a value because we just copy pasted that it's set to my offset. But let's create a new one so we have a real important value. To do that, let's open up our workshop chop header and go back to our class definition. So inside of the class, we can just add. If you scroll down, you're gonna see there's already the value called my offset inside of the private section. Let's create another one called my total. So inside of the header, you can create it. And then go back to the C++ file, and we will need to initialize it when we create the object. So to do this, you just have to go back to the constructor. Let me just real quick. Okay. And right here, we could just write my total. So this way, it starts at 0 whenever we create the object. And then inside of our logic, inside our execute, maybe every frame we want it to go back to 0 at start. So you see, is already the example already does that with the my execute count, but every frame it increments by 1. But here we're going to do it another way, my total. So this way, every time we start a new frame, we start at 0. And then inside our logic, maybe just after we set the total in the channel, we can also increment our total by the local variable this way. So it's pretty like random value, but at least we're going to see it move. So once this is done, we can go back to the dat function. So at the end, and instead of outputting my offset, I could put my total right here. And so right now it should show something different. So let's go ahead maybe and compile. And to see if it worked, you can go ahead and create a dat, an info dat, and you can link it to the to your custom shop. And if you click combine, you can see that the value changes. And if you unclick it, it should stay to 0 because you're never initializing it. Well, you're never changing the value. So does everyone have like a new row inside of this info dat? So right now, maybe I can take some time and take a look at all the small errors we have, and like go over this and like just be sure that everything is on the same spot. And then afterwards, we can create another new object. So does anybody have some compile errors right now? Okay, I can take a look. And everyone, we can take maybe just 5 minutes, not much. And I can put back the code. So right here. Okay, I'm gonna take a look at everything. So
Right now, I think I'm just missing a curly brace somewhere.
yeah, looks like something like that.
I was trying to keep up, so finding it.
If you go, maybe when you initialized your yeah, maybe right there. It looks like right here. You see this one?
I'm missing a curly.
No, you have to remove it. Also, I don't know if you heard earlier, but if let's say you select all this block, but not the last bit. Yeah, just this, and then you click tab. Did you know about this trick? But it's nice just so you can organize your code better.
And then the other thing.
Oh, by the way, don't forget to stop and recompile after that, just to see if it works. Like right now, we have to see how we can adjust what's left because we kind of went a little bit overboard. But if we miss anything, I can just show afterward. And anyway, it's written in the README at the end. It's very straightforward in what I put. Yeah, basically you just compile in release mode and put it back here. Put your DLL inside a custom folder, and it's gonna show up. Yeah, so I'm gonna show it at the end anyway. Okay, so are we ready to continue a little bit further? So we're gonna kind of stop using this code base and hop on the new code I sent you this morning for the Wiimote shop. What's nice is that we don't have to rename everything and redo all the stuff. Only thing is you might need to relink the master file correctly because your settings might differ. But at least you won't have to redo all the renaming and stuff like that. Let's just have a look at the README. So I can just go over the logic behind integrating a new detector inside of Touch. Basically, you want to have a look around on the internet and see are there any SDKs available or APIs. Let's say you want to integrate a SICK LiDAR or maybe a Modbus, an old old stuff. Are there any libraries that already exist? Sometimes they're inside of Windows. There are already some SDKs. For instance, once I integrated an RFID reader system. You can do it in Python, but inside of C++, there's already built-in functionalities at the core of the system, operating system that you can use. So this is nice to find. After that, if I find some stuff like this, I start using some of the libraries and test them inside of a command prompt application. For instance, this is what I did for the Wiimote. I found on the internet a lot of different libraries, but one seemed to come out a little bit stronger. It's called WeUse. I think I linked it inside of the README, but it's a multiple OS, so and it's supported. So when I found it, I said, okay, I'm going to create a small program. There's even some example files that you can look at. I included it inside of this repository, so we're going to have a look at it together. And once I have a small program working in command prompt, I basically have everything I need to integrate it in TouchDesigner, because it's basically almost copy-paste at this point. You're going to have a custom object, and you just want to implement it inside what we looked at this morning. It's not that straightforward, but like that's the path. So for now, I basically did step 1, 2, 3 for you, and we're going to start at the step 4, which is basically integrating this logic inside of TouchDesigner. But in order to have it working correctly, we're not going to have to check if all the Wiimotes, if you can connect it on your PC. So inside of, just look at the code base I gave you. You should have a folder called WePair. I think it's one dash WePair executable. Let me just have a look. WePair executable, and there should be a .exe file. So since this is Bluetooth, we're going to have to do one by one because we don't want to bump into each other. But basically, when you're going to run it, it's going to ask you how many Wiimotes. You just put one. Do you want to remove the old Wiimotes? Say yes. And then after that, well, I can do it on my side so you can see. Maybe I can need some help to put some batteries inside of the Wiimotes if someone wants their batteries in this one. Okay, cool. I'm gonna take the ugly one. It's a fake, but it works. Yeah, but some work, some don't. But now I'm a Wiimote expert. I never knew it before. So basically, maybe you can go back and bring one to everyone, but make sure they don't all flash blue. To remove the flashing, you can just remove the battery. But yeah, when you give it to the people, they can just so that it doesn't bump into each other. So I'm going to go ahead and show you how the small program works. Basically, it's just because you know how Bluetooth on Windows or any OS is, sometimes you have some devices that are made to work for Windows, but since it's a Wiimote, it's kind of a hack. So you need to have a small Bluetooth connector, but depending on the detector, you won't have to do this. It's just basically for the Wiimote. So there, inside of the WePair executable, you can just run the software. But like I said, I'm going to do it first, and then we can go maybe clockwise, and so we don't bump into each other. And did you download the repository? Okay, inside of this, there's a folder called one. The first one, one. Okay, so should you remove? Yes. Okay, it's gonna look at. You might not have any Wiimotes connected yet. This is because I did it already. And then you will need to pair. I click on the keyboard and I click behind. There's a red button inside the battery, and it's gonna start looking for the Wiimote. It says found. I need to wait. Completed successfully, and once it's done, you can just close this software. So maybe you can go ahead and do it. And so while everyone start to get their Wiimote ready, we can already just open the solution, which is you can see in the folder you have basically the same stuff that before, but already named with the Wiimote name. Does it seem to be working, or? Okay, yeah, you gotta wait a little bit. It's gonna. You might if it stops blinking, you might have to redo it or re-click. Maybe you can just hit Control-C and restart over. But make sure maybe you push the button when it says push the button. This is why we have to do it like. Did you do it already? Yes. Did it say found one? Okay, so you should, if it says good, it should be good. So at first it's going to say scanning for Wiimote because it want to remove the old one, but after that it's going to say again. Okay, if you click now. On no, I mean on the Wiimote, yeah. Okay, but I think there might be some bumps. Okay, I think you can exit it, but oh no, wait a little bit. Yeah. Maybe Alex, tu veux juste essayer voir? Let's just maybe you can go ahead and try and see. We're gonna have to. Es-tu parti? Ok. Press any key to continue. Ok, faut-tu. Y a-tu. Ah, c'est parce que t'as double-cliqué tantôt. Ça se peut-tu? Ok, là, pèse sur le bouton. Puis là, pèse sur le clavier après. Ok. Ok, c'est bon. Okay, maybe Matthew, now you can try. I'm going to check at the end, but I don't know if maybe it bumped. It's normal that it keeps blinking. So you have to press some keys on the keyboard to go forward. So right now it says remove previous, so you can press a key. That's going to wait to find if it's the old devices. And now you can press the red button and press the keyboard. Well, this seems like a Murphy's Law kind of thing. So maybe we're going to have to just look at the code and not have the Wiimote working because there seems to be some stuff with the Bluetooth. But maybe we can just try and see how many works, and we can try to have the most working. And I tried to find a detector not too complicated, but it seems to be causing some issues. First thing first, like I said, I found some libraries online, which called We Use, and we want to work with this library. So how can you link it? This is the first step. So if we take a look at the project Remote Shop, when you are working with libraries, you will have a .lib file. If we look inside of our code base, you can go in, you have two folders which are important. One is called includes. What you see, it's called weuse.h. And the other folder is called libs. Inside of x64, you have weuse.dll and weuse.lib. Basically, the weuse.dll is the compiled version of the code base we're going to use, and the .lib version is the version we're going to use to link to our compiler to develop. And like in the other one, the weuse.h, it's basically a header file that tells our software what functionalities are inside the other library. So you need to include those two files inside of your project. How do you do that? You can right-click your project, Remote Shop, and you can then go to Properties, and inside of you have two places important. One is the C++. You can see there's already additional include directories, and there should be already a value because I placed it first. What's nice is you can see you can use some vars inside of Visual Studio. This one is by the $sign. It means it's a variable. Solution dir, which means it's the path to the current directory, and includes. So basically, it's going to include the file I just showed you inside of the code base. The other place important is the linker inside of here. You can see at the general additional library directories. Like you could have different libraries located elsewhere on your drive, but for now we put it inside of the same folder. And once again, you can see I already placed it for you. It's called solution dir libs.x64. So basically, when you compile, it's going to look for the include directory for the header file, and it's going to link these libraries dynamically when you compile. So this is already a great start. And just to see if it works, we can compile and just see if everything pops up. You might get an error because the path to TouchDesigner is not great, or the master, the link to the file is not correct. But if you remember from earlier how to modify it, if not, I can just show you real quick. Oops. I'm just going to close my old project. Also, there might be already a TouchDesigner.to file that is linked. You will also, maybe you will need to change it. If you don't remember, it's inside of the properties, debugging, and then right here, you can change it if it's not good. Also for the command arguments. And when you compile, so it should open the example, which is basically just the C++ chop empty. Maybe just change the path inside of this chop because I think it's hard-coded. This path, yeah, it's the old place. So if you want to change it, well, you remember you can just click on the plus and go inside this directory inside of debug, and then you should have remote chop.dll. And for the moment, I do nothing. It's just the sine wave because we're starting from scratch. So go ahead and save this version. And you can close TouchDesigner. So if we take back a look at our code base, if you remember, we had only four files earlier. Right now we have 6, well, excluding the GL extensions. So there's two new ones. You have the Wiimote connector as well, both the header file as well as the C++ file. So basically, this is an object. So maybe you're familiar with objects in C++. We just used a bunch earlier that were the default one TouchDesigner gives us. But what's nice when you create a new implementation, you're going to want to create your own objects. So just by looking at the Wiimote connector header file, you can see I created a class with already some small functions inside of it. So you see, we have the constructor, destructor, classic stuff. But I already included some function that I know we might want to use later. One is called update. So basically, every frame, we're going to tell the Wiimote to update itself, update the data. Also, I put get current status. Like I said earlier, it's nice to have a string representation of the status. Let's say Bluetooth disconnected, just all the mistakes we have, the problems we have right now, we can output it inside of the info.dat. So we might need a function to fetch this information. And inside of a private, we have some other stuff like the initializing code for the Wiimote, or here you're going to see some stuff I'm going to show you a little bit later, but a pointer to the Wiimotes as well as the string to the status of the Wiimote. So basically just some stuff to get started. Also, if you take a look inside of the files, inside of the directories, there should be one. Hopefully, it's there. I think I forgot to implement it. Oh no, we use the LL example. Okay, so inside of this folder 3, we use the LL example. There's a file called example.c. Okay, so this we won't compile it, but it's an example file of the library of the Wiimote. So it's always good to take a look at this while you're developing, so you can know what you're going to do. So maybe just open it inside another tab. You can drag and drop, or click File, Open, and open it. And just taking a look at it, you can already see that, first of all, this coding style is a little bit different, but you can see all stuff from the Wiimote. Motion plus is button press, stuff like that. And if we just scroll to the main function, basically the main function of the program, you should find it kind of further down. It's on line 406. You can see there's the main functionality, but we can look at this and inspire ourselves. So already you can see the same pointer that I had in my connector. Here in our header for the Wiimote connector, we have this parameter. Well, it's just a copy. It's just a way to hold all of our Wiimotes inside one spot. So like we already compiled, but we just got the basic sine wave from the example. So is there a way, first of all, to create the object and start speaking with it? So that's what we're going to do. If we go inside so just to make sure, you have the Wiimote connector, which is our object, and we have the Wiimote chop, which is the TouchDesigner object. So we want to have the TouchDesigner object have an instance of the Wiimote connector object. So we're going to go inside of the Wiimote chop header file. And you remember when we created a custom value inside of earlier that it was called my total, but right now we're going to create one for the Wiimote. First of all, we will need to include the correct object. So include Wiimote connector .h. So this way we have the code included in the software. And when we have it, we can just create one right here. And I like to keep my things in pointers. So Wiimote connector pointer, and maybe call it my Wiimote or something like that. So right now, if you included the file correctly, it should stay green. So meaning it's correct. But right now, this won't do much because we just created an empty Wiimote object. We will need to initialize it. If you go back inside the Wiimote chop, so the TouchDesigner object, you remember where we set our earlier our my total variable to 0. Here we're going to do the same thing, but we're going to initialize the Wiimote connector object. So if we go ahead and write my Wiimote, whoops. So right now, at least the object should initialize. So if the code, the color changes, it means like at least you have somewhere to know you didn't put a small syntax error or something like that. And so now we have an object that doesn't do anything. Maybe we can go inside of, because if you go back and look at the Wiimote connector, but the C++ file, you can see, well, all the basic functions are there. You can see I put my status at initializing. So, and also already in the function get current status, I return the status. So maybe we can just show the status inside of the info dat. So at least we know that we have an object working somewhere. So if we go back to the TouchDesigner object, you remember the last thing we did before the pause was adding a new row to the info dat. maybe let's go ahead and do that. So inside of the info dat size, add a new row. And then inside of the info dat entries, we can create a new entry. So once again, index 2. Here we could change the name to Wiimote status, something like that. But so let's just stop and think a little bit. Here you can see entries, value, set string, temp buffer. So here it already waits for a string. So we don't necessarily need to create this. This basically, it creates a buffer. It takes this value, which is an integer, and put it inside this buffer. We won't need this because we already have a string. So you can just comment out. And you can create maybe a string. So once again, std string, and call it maybe the current status. And then how can we fetch the status? We're going to just call the method getCurrentStatus. So our object, my Wiimote, calling the function. We already see all the tree we have available, getCurrentStatus. So this, now we have the string. And if we were to go ahead and put this inside here, once again, it throws a small error. Remember the thing I told about using old C strings? So just put a small conversion to the string, .c underscore string, so that it converts to the correct format. So theoretically, right now, we have something like that should show something. So maybe I can just put the code for 1 minute, and after we can try compiling. Syntax error. Maybe some include didn't go correctly. Okay, so to do this, you can right-click on the project, properties, and then general. Okay, platform toolset here. Click on this. You can click on V4, the one you have at the top, the first one, and then apply. It's going to convert because you're using 2017.
Okay.
So I don't know if other people got this error, but it's using a little older version of Visual Studio. So basically it's saying that the Visual Studio V142 is not found, the platform toolset. If you have this mistake, you can just change to an older version. It should work. But if you don't have it, I think we can continue. Okay, maybe close this. Go back to the project. Right-click on this. Yeah. Click on properties. Inside general. Here you see V142, and yeah, exactly. It shows the first one, and now in theory it shouldn't cause any issues. So this one, the initialization. Right here. So basically, this is where you you create a new instance of the Wiimote connector. So if you are already ready, you could compile and put an info dat. And in theory, you should already see a line. It should say initializing. If it says initializing, it means that you have an object correctly working. Because right now you're basically calling the. So I'm gonna just show it so that everyone can see. But in theory, it should be it should be showing up. So yeah, I got it myself, the initializing. I'm going to save this file like this. So once again, we're going to create one thing important when you're working with detectors is you might not want, when you load the DLL, you don't want it to connect automatically to the detector, because sometimes, let's say you're working with a network object and the object is not found on the network. If you load the DLL and you don't have any code to handle an IP address not found or something like that, you're going to crash your sketch. So one thing I like to do is, you remember when we created a toggle for the in the first part of the workshop, is just to have a toggle on off, so I have it at false by default, so it's off, and when you click on, it's connecting. This way, if you have a project in TouchDesigner, it won't crash every time you load the DLL if it doesn't find the object. So the next part would be to create a new toggle and call it, maybe just call it Wiimote. Don't put any spaces for the moment, because there's a different way to handle the spaces in the name. Just put Wiimote. We're going to go ahead and create this toggle, and after that, we can create the code for the connection of the Wiimote. So the DLL. So the DLL, it should be inside of the current folder. So for instance, it's a Wiimote chop clean base, and there's a folder created called debug. So basically, the DLL should be inside of it. And so here you can go ahead and link it. Are you inside of the Wiimote chop clean base? So basically, same thing as before for the 141. You have maybe just an older build of Windows, so you need to retarget. But if you, how I found out, you saw at the bottom, it said in the output, it said like invalid Windows 10. So basically the same kind of error that was there before. So this is two things. Yeah, so now you can save this version. And did you do all the other manipulation to create the? Okay, cool. Okay, so there's still a lot of stuff to cover, and we're gonna maybe run out of time. But what I think we can do before the workshop ends is we can go up until we connect to the Wiimote and have we can make it vibrate so you know it's connecting. So this, I think we're gonna have time to go there. But there's some other stuff further that's like multi-threading, and but we won't have time today to go into these details. But I can go over this in discussions, or maybe if you have some other question afterward. So, like, if we go back to this, maybe some of you already took some advance and created a toggle, but I'm going to go ahead and create it myself. So, inside, if you remember, it should be inside of the setup parameters method, inside of the Wiimote chop. Always important to put small comments. And let's call it Wiimote. Okay, so now what we want to do is when we're going to click, if the old value, if the previous value was false, we want to tell the Wiimote connect to the Wiimote. Well, the object, we want to tell it to connect. So to do this, we might need to hold somewhere we need to know what was the previous value. So once again, you can go back to your Wiimote chop.h where you created the Wiimote pointer. Underneath, you could create just a small Boolean saying maybe last Wiimote toggle or something like that, just so we have somewhere to store it. So it doesn't matter the name. And then go back to your constructor So at the beginning of the remote shop.c++, where you create the initialization of the object, my remote. Over there, you can just put last remote toggle and put it to false. This way, we can know when we click it just to call the connection script once. So we don't connect every frame. This would make this would be nonsense. So when we have this, we can go inside of the execute function where everything happens, and then we can start looking for the connection script. So first of all, once again, let's see if the toggle is on. So a Boolean with is remote on, and then we check the inputs. And so now we can have a small if to tell the remote to connect. So if not, so you know the exclamation point to say inverse. So if not last remote toggle. So if the old value was false, and if the remote button is on, so if we just clicked it basically, we can have we can call our object my remote and then tell it to connect. So right now we don't have any function or method that does that, but let's just call it like that. It should throw an error. And we're going to go ahead and go create this, but just before, well, we still keep this rubbish code for the moment because we don't want to change it right now. But since we want the last remote toggle to hold the frame from the last state, at the end of this function, you want to update its status. So basically, at the end of the frame, you want to save the value of the toggle button. So just underneath, you can just write last remote toggle equals is remote on. This way, like I said, you will just call you will just call the connect function once, and you won't spam it. Whoops, I've kind of made a. Okay, so now the function doesn't exist yet, so we're gonna go ahead and create it. If we go inside our remote connector, it's going to be a public function because we want everyone to be able to call it. So let's create it. Just maybe underneath update, void connect. And then we're going to go ahead and define it inside of the remote connector C++ file. So just maybe you can copy this empty function and then create the connection script. So since we already wrote kind of a few lines, I already like to test and see if nothing is broken. But what could we test? Maybe right now we can just test, set the status to connecting. So this way we know that our object has been updated. So let's just go ahead and create and change the status. So underscore my status equals connecting. This way, we're going to have a way to know that the toggle did work and that we can go ahead and continue. So I'm just going to go ahead and compile it, and I'm going to put up the code back just after. And just to, if you want to confirm it working, like I said, you go to custom. Now you should have your toggle. And if you click on the pulse, the status just changed to connecting. So we definitely have a proof that this function is getting called. And if you go ahead and you toggle it off, it stays to connecting because we're not doing anything new afterwards. But we could envision having a function like disconnecting and maybe change the status over there. But for the moment, at least it's a good starting point. Are you up to everybody has this working? Okay, so this is where since now we have a proof that the connect function is getting called, we will want to connect for real to the Wiimote. So how do we do this? Well, this is when you have to look at the example code to start getting real inspiration. So let's open up the example.c file and go back to the main function. So just reading, first of all, reading real quick. You have some int at the beginning, found, connected. It's kind of straightforward. Here you can see initialize the array of the Wiimote. You can see that after that, it tries to find the Wiimotes, and then it tries to connect, and then even further, Wiimote set LEDs. Okay, so we can kind of see what's happening here. So let's go ahead at the beginning and try to start implementing this functionality. So we will need those two variables as well as this first part of the script. So we can just copy it and go back inside our own Wiimote connector, inside of our connecting script. So just put it like this. And right away, it says that Wiimotes is undefined. Well, if you just go back, Wiimote here, this version, we didn't name it like this. Actually, it's named, it should be named underscore Wiimotes like this. So you can just replace this because we want the object to have a reference to this array for the rest of its existence. So this is the first part. Also, I like to keep the comments, and further down the line when you do optimization, you can remove and change the stuff, but for now it's important to have everything. So now we can go back to the example, scroll down a little bit, and copy this part. Once again, you will need to adapt a little bit. So instead of having this array, once again, we have this one. And right underneath, you have two things. First, return 0. We created a void function, so we don't return anything. So this, if you just look at the code, if nothing found, no Wiimotes found. So we want to keep this part, but we won't return 0. We will just return from the function, so it exists in case there's an error. And now it should be okay. And also printf. I don't think it's you can't print f inside of the console in TouchDesigner. So remember when we set the environment variable at the beginning, we're going to use this right now. But instead of using printf, we're going to use cout. So maybe you're familiar with it. It's a basic functionality to output text in the console. So instead of having the printf, whoops, you can comment this out. You're going to write std cout. So right now I don't have it included, so I will need to include the library. Let's just go at the top of the file. Here you can include IO stream, IO for input output stream. So because the function has not been found, it's a part of the basic library IO stream. So add it and go back to the std. So now cout is found. And the way you output is this thing. I don't know what it's called in English, but so you just write. It's the direction it's pointing to is going to output this way. So copy the string you want to output. So now, at least inside of TouchDesigner, inside of the console, we're going to have this message if this error hits. So if we go back to the example file once more, and keep continuing down the script, connecting to the Wiimotes. Once again, just copy and paste it. Once more, you need to adapt the version of the script. So instead of using this array, you need to change it to our array. And here, the printf, we will need to modify it a little bit. So you can comment it out and create a cout. So just this one, you see it's kind of special. It's dynamically creating the variable inside of the script in order to do this on our side, we will need to just copy some parts of the script one by one. So you need to connect it to. Then if you want to output a variable, you need to put again this this double thing connected. You can copy this. You can tell it's a variable because there's the percentage sign in front of it. So you just copy between them like this. And then the last part. Okay. So basically, this is a string. This is a variable. This is another string, another variable. Just so we have a small output of what's going on. And you need to change it here also. So comment out this part. Also, don't forget to remove the returning 0, so you don't return, whoops, you don't return a value. And so we're almost done. So if right now in theory, the Wiimote should connect around here, else it should fail to connect. So let's take a look at the rest of the code. Now, if we want to prove that the Wiimote connected, we can just check this function. We use set LEDs. I think it's pretty self-explanatory. So let's just go ahead and take this one and then copy it right after connected. So if we successfully connect, we're going to set the LED to 1. And don't forget to change, once again, this array to the correct one. Also, there's a functionality called the rumble. So we're just going to make it maybe rumble like for 200 milliseconds, something like that. So go ahead and copy this version. And this is kind of bad practice, but we're going to just put a sleep so it sleeps for 200 milliseconds before stopping the rumble. But I'll tell you why it's not the best idea right after. But for the moment, just put sleep 200. And then if you copy this line once again, put it to 0. So it's going to rumble 200 milliseconds, then it stops. And then finally, we could set the Wiimote status to connected. So we have a way to know it's successfully connected. So my status. So I think for now we have almost everything. Maybe we can just go and check for the rest of the code. Okay, so from looking at it, the rest seems to be, if you look at it, we use poll, any remote connected. This seems to be more the polling features of the sensors. So the connection script seems to be done. So just go back here and I think we're ready to compile. So let's go ahead and try it. So everyone that had the Wiimote that did connect for real, make sure it's actually open. And so I have a script error, something like that. Okay, one thing important, since we are working with an external library, when you're running inside of TouchDesigner, you will also need to include this DLL. So this makes 2 DLL. Basically, you have your chop DLL that you're going to link, but you also need to link all the other required. Sometimes there's like 5, 6. You need to include them. So how are we going to do this? First, you can close Touch for the moment. Go back inside your directory where you have your solution. And so I already compiled the weuse.dll earlier. So if you go inside libs, x64, weuse.dll, you can just copy this DLL and then put it in the same location of your chop DLL. So for us, it's inside the debug folder. You can just copy and paste it over there. So to make sure, just make sure remote chop DLL is here. Okay, it's inside of the debug folder. You copy it there, and then once it's done, you just compile again, and now this shouldn't be an issue anymore. But this doesn't tell you, so you just have to know it. I'm sorry. What did it says unable to load DLL, but it doesn't say it's the other one. It just says unable, so you don't know, and you don't even have an error. So it vibrated. So yeah, basically, if you go in custom and you click the remote button, so I just crashed my sketch because we don't have any way. Now it vibrated for me. So basically, and if I look at here, remote status connected. So, well, the connection script works, but like I said, we don't have a lot of more time, so we won't be able to pull the data. But I can still show you something interesting. Is let's say we had the time to finish all the polling and all this stuff. Now inside of TouchDesigner, you have this new tab that's called Custom. So when you're done with your object, you can actually compile them and create so that they appear inside of all these tabs. Well, in the custom tab. So we're gonna go ahead and do this with this object, even though it's not finished yet, but for the sake of it. So did everyone actually successfully compile, or did it have any issues? We can check after since we have like 30 minutes left. I think we can just at least reach this point, but just for the moment, I'm gonna show you how to export your object at the end. Right now, you see we've been in debug mode for the past, 3 hours. When you're done, theoretically, you compile as a release object. So what you're gonna do is change your setting to release. And now you can just compile it by clicking this button. And once again, for me, it tells me unable to start program because for the same reason we had at the beginning. I didn't link TouchDesigner because now you link TouchDesigner with your debug version, but not with your release. But we don't care. We just want to look at build succeeded. So if the build is successful, you can go back inside your code repository where you have debug, and now you should have a new folder called release with the actual remote chop existing. So the way to include it now in TouchDesigner would be to navigate inside of your documents, and there should be a folder called derivative right here. And now you have palette. Maybe if it doesn't exist yet, you can create it. I think you need to call it plugins. Let me just check. But this is part of the documentation you can find on the derivative wiki. But if we can go ahead and just create it, call it plugins. And then you can copy your DLL over there. And don't forget what I just said. You also need to copy all the necessary DLL inside of this one. So go back to maybe your debug and copy the weuse.dll inside of this folder as well. So right now we have 2 DLL inside of the plugins folder. And now the next time we're going to start TouchDesigner is going to say, hey, there's a new object found. Do you want to use it? So if we just go ahead and try to start Touch. Like I said, the plugin hasn't been loaded before. Do you want to start using it? Yes. And it should be in custom. So right now it's called custom signal, but it got the same settings, so remote and stuff like that. One thing we didn't do is change the name of the op and stuff like that. This is done actually. Remember at the very beginning of the workshop, if you go back to the remote chop.c++, almost at the beginning of the file, line 27, you can find this fill chop plugin info. So right now you can see custom signal. So that's why it shows up at custom signal. But if you were to release it for real, you could write remote chop, whatever, change your name. and then it would show up as Wiimote instead of custom signal. Of course, you would need to remove the old DLL and replace it. But this is one nice way after that to share. I think that's the way going forward because it's a new feature from like maybe not even 6 months. So that's kind of nice that we have this now. And I think for now, we can just conclude by trying to make the last, everybody who didn't successfully compile, I can go ahead and check with you. Okay, on the wiki, there's a page called Custom Operators, and there's actually a subject called Importing your using custom ops plugin folder location. Actually, at the end of my README, there's a link to it. So maybe inside of it, we can check. Okay. Anyway, I think I'm gonna just conclude, and maybe we can like. I think I might do a video or something like that after to just wrap everything. So. So yeah, guys, I think we're almost gonna conclude because it's we don't have any more time. I thought it would be just enough to have one morning to do this, but maybe we would have needed more time. So sorry for that. But what I think I'll do, because I can basically do. I already did a small video on YouTube video, but it's in private. But I'll redo another one, put it public, and it's 3 hours long. But at least you will get the full feature of this. You won't necessarily have the Wiimote though, but you'll get to see everything. One important stuff that we would have found later is that now, okay, we are successfully connecting on the Wiimote, but the DLL and that we create is running inside of the same thread as TouchDesigner. So just by looking at the code, just real quick, the example code, if you scroll down, you can see there's a while loop right here. And while infinite loops are killers because it's gonna basically loop indefinitely, and TouchDesigner is gonna freeze inside of this loop forever. So this is why when working with like detectors like this, you want to have to have your logic, the polling logic, inside its own thread, so that it runs on the side. And instead of calling the poll every frame, you're just going to fetch the data every frame. So the polling logic happens on its side. It might be at 10 hertz, 100 hertz, whatever, but at least you don't like break your software. And it seems harder than it is really, because threading a function is like just calling a thread and handling it correctly. But like I said, I think, since we don't have any more time, first of all, I'm here for the whole weekend. If you have any other question, don't hesitate. The file is going to be public. The README, you have everything you need in this. And like I said, I think just polishing a small video, and I'm going to put it for you guys. So and if we have the chance, maybe do another workshop and go into more further details in the next, maybe not next year, maybe hopefully before that. But yeah, thanks. I hope you had some fun going deep inside of C++ like that. And thanks a lot, man.